Hello, hi, I'm Punita here from Huawei Global Training Center, and today we're going to discuss about the content typical indoor site coverage solution. So let's look into the BBU power supply solution in indoor coverage. So the BBU power supply solution in indoor coverage, the BBU obtains power from DC power supply cabinet by default. The DC-DU module is configured only when the BBU and RRU have centralized power supply requirements, and the power cable length of BBU is 5 meter by default. There should be a site survey remark for 10 meter or 20 meter if the required length exceeds 5 meter. So the maximum length of the cable is 20 meter if there is a special requirement. So the recommended air breaker specification is 16 ampere when the BBU directly obtains the power from the cabinet. So basically the BBU will be installed in the OMB and use about 200 voltage AC power supply. This solution is applicable to scenarios having dust-proof requirements such as BBU installed in the current wells and also the underground garage. So this is a sample of dust-proof requirement which we'll be looking at the later part of the session. So let's go through the indoor distribution site solution. So we have a diagram here which we will see what are the components available. So we have AC distribution box. So basically we have the DC power cable. So this one is DC power cable going through the module RRU. Then we have the jumper. We have the jumper, we have the ground bar. So this one is actually the jumper, ground bar, and we have the protection cable. So the yellow color one is actually the CPRI cable. This is a feeder, the green one, and we have the CPRI cable over here also. So we also have the jumper. Alright, so we have the ground bar, the grounding cable. The green color one is pointing to the grounding cable towards the RRU, and also with the ground bar. We also have the jumpers AC power cable. The pink color one is actually referring to the AC power cable, and the red color one is referring to the AC power cable as well. So we also have the GPS arrestor, the pink color box here, and it's inclusive of the grounding cable together with the grounding cable. And the yellow cable here is referring to the ODF. The black color one is actually referring to the ODF model. So basically this is referring to the distributions from the cables to the RRU and also to the BBU model. So on the top here we have the GPS antenna with the GPS feeder. So the green color cable is referring to the GPS feeder. So this figure is basically referring to typical AC distributed power supply site solution. If the centralized AC power supply is used, all the power cables for the BBU and RRU are routed out from the distribution box, like how you see over here. If the centralized DC power supply is used, the DC-DU will provide power. So DC-DU we can find from the BBU model. It will provide power to the BBU and RRU in a unified manner. So indoor coverage indicates that RRUs are installed indoors. The typical configuration scheme is the same as the outdoor scenario with no remote RRUs. So let's look into the LTE indoor coverage site solution. So we have 4 solutions for new sites and all of them are installed indoor. The BBOs are installed indoor, and basically the power supply is divided into DC and also AC. In terms of the equipment, in terms of the installation space of the equipment room, for solution 1 it's sufficient with the BBU installation method using cabinet IRC29. For solution 2, we have 2 categories. One is insufficient. The second one is sufficient room, but RRUs cannot be mounted on the wall. So for this case, we have 2 types of solution. We are going to use the cabinet model of IMB03 and the indoor floor solution. For solution 3 is also same as solution 2, where we're going to use IMB03 module for the cabinet type and also the indoor floor solution for the rack, for the RRU rack. And the solution 4 is about dust protection requirement, which requires the cabinet OMB. So dust requires a dust proof requirements. Basically, the BBU will be installed in the OMB and it will be using about 220 voltage AC power supply. So basically, this solution will be applicable where the BBU will be installed in the current valves and also in the underground garage. So let's look into solution 1. New indoor site coverage. BBUs are located in the room, minus voltage DC power supply, sufficient space, cabinet type, ILC29. So over here, minus 48 voltage DC power supply will go to the DCDU, and from the DCDU, the power will go to the BBU and also to the RRU. So they are using ILC29 cabinet. So minus 48 voltage will go to the DCDU model, and from the DCDU, power will be supplied to the BBU and RRU. So this is the power supply logic relationship for the typical configured component quantity. We need 1 BBU, 3 RRU, 1 DCDU and 1 indoor ILC29 cabinet. So let's go to solution 2. New indoor site coverage. BBUs are located in the room, minus 48 voltage DC power supply, insufficient space, IMB03. So minus voltage DC power will be going to the DCDU. From the DCDU, power will be supplied to the BBU and also the RRU in the IMB03 module. And for the indoor floor solution, we have the RRUs installed there. So minus voltage DC power supply will go to the DCDU, and from the DCDU, power will be supplied equally to the BBU and to the RRUs. So this is the power supply logic relationship. For the typical configured component quantity, we need 1 BBU, 3 RRUs, 1 DCDU, 1 IMB03. So the installation mode is wall mounted. Solution 3. This is new indoor site coverage. BBUs are located in the room, 200 voltage AC power supply used, insufficient space, and we are using the cabinet IMB03. So 200 voltage AC power will go through the ETP module, and from the ETP module the power will be supplied to the BBU and also to the RRU, and this is in the cabinet IMB03, and RRUs will be stacked at the indoor floor solution. So 200 voltage AC power will go through IMB03. From the IMB03, minus 48 voltage DC power will be supplied via the DCDU module to the BBU and RRU. So this is the power supply logic relationship. So typical configured quantity is 1 BBU, 3 RRU, ETP module is 1, IMB03 module is 1. It will be a wall mounted scenario. AC power input 20 ampere for 1 PSU and 32 ampere for 2 PSU. And solution 4. Solution 4 is related to indoor site coverage as well. BBUs are located in the room, 200 voltage power supply, insufficient space, and OMB version A cabinet will be used. 200 voltage AC power will be supplied to the EPS module 304815. From this EPS module, power will be distributed to BBU, and minus 48 voltage DC power will be supplied to the RRU. So OMB version A cabinet will be used here. So from the 220 voltage AC module will go to the OMB. So the BBU installed in the OMB will use 200 voltage AC power supply, and from that OMB through the DCDU model, minus 48 voltage DC power will be supplied to the BBU and RRU. So this solution is applicable to scenarios having dust-proof requirements. So the BBUs will be installed in the current wells or probably underground garage. So this is the power supply logic relationship. So typical configured component quantity, we have 1 BBU, 1 OMB, 1 RRU, and OMB version A installation mode is wall mounted. For the breaker specification, we are using 10 ampere AC power input breaker is recommended. Q&A session, true or false? The BBU installed in the OMB uses 110 voltage AC power supply. This solution is applicable to scenario having dust-proof requirements such as BBU installed in the weak current wells and underground garage. This statement is true or false? It is false. We are using 200 voltage AC, not 110. And the power cable length of BBU is 5 meter by default. There should be a site survey remark for 10 meter or 20 meter if the required length exceeds 5 meter. This statement is true. So, the summary of typical indoor site coverage solution is that we discuss about BBU power supply solution in indoor coverage, indoor distribution site solution, LT indoor coverage site solution, solution 1, 2, 3, 4 for new indoor site coverage. So, that's all for me. Hope you enjoyed the session. Thank you and bye.